One of the very last things in your last unit talked about intercepts. Yeah, on the review. And it leads directly into this. So an X-intercept. What does the word intercept mean? Crossover. Right? So an X-intercept is when a graphed line, and it needn't be a straight line, but in grade 10 it's always a straight line. When a graphed line crosses the x-axis. Easy peasy lemon squeezy. So what then, obviously, is a y-intercept? When a graphed line, and again, it doesn't need to be straight, when a graphed line crosses the y-axis. Yeah? Easy peasy. How many times will a straight line cross the x-axis? Once or nonce, right? It doesn't have to cross the x-axis if it is straight horizontal, correct? So a line will cross the x-axis once or never. How many times will a straight line, cross the y-axis? Once or nonce. Nonce isn't a word, I just like to say it. Okay? All right. So there is on a straight line, there's one or none. When there's one, it's a diagonal line. When there's none, I'll put a box around that. None is diagonal, or one is diagonal. If there's none, it's a vertical, or a horizontal line. Because that line will never touch the x-axis, unless it is right along the x-axis. Everybody cool? Now, obviously, being the intelligent people you are, on a straight line, there's, again, one, it's diagonal, or none, it's flat. Now, let us, cabbages, put that into practical terms. Here is our lovely and talented Cartesian plane. So make yourself a big old X and Y axis and draw a line anywhere on it that touches both the X and the Y axis. Doesn't matter where you draw the line. Everybody draw the line. Do not wait for me to draw a line and draw my line. You draw your line. All you have to do is make sure it is a straight line that hits both the y-axis and the x-axis. It can be anywhere in your graph. I am going to put mine right here. Oh! Preston.
Does it have to go through the line? Like the middle line?
Yes, because I want an x and a y intercept.
But doesn't the y go through all of the vertical nodes?
No, dude, because it's only the time it crosses the axis. We're not talking about domains and ranges.
What if it's in the center?
If it's right through there,
Yeah.
well, then it's hitting the x and the y axis right at 0. So you know the answer.
Oh, it's correct.
Now, here, where in my drawing is the x-intercept? Is it point A or point B? It is point B. This is my x-intercept.
Wait. I don't get how it's point B. She just named
It is that point because that is where my line crosses the x-axis. We just defined that. Okay. What do you know about that point? It has a number, right? What is that number? No. It is made up of two numbers, correct? One of them is an X, one of them is a Y. What are those numbers? Which is the 0, Selena? The Y is 0. You can quite plainly see it is not X because I am off of 0x. What can I write there? No.
Any whole number.
I can write X because I have no idea where I am on the x-axis, but I know I am exactly 0 on the y-axis. This is the coordinates of every x-intercept. It is always x comma 0 because you have no idea where it is on the x-axis, but you know that it is 0 on the y-axis. Does everybody understand? Now, being the intelligent young people that you are, what is that?
Actually, I have a quick question.
Oh, sure.
I put my line so that the x-intercept is like on the other side.
We'll talk about that in a sec.
Oh.
This is the y-intercept, which means it is what? 0, comma, y. And that is the coordinates of every y-intercept. Does everybody understand? Now, let's address the Catherine that question just had. The question that Catherine just had. She had her x-intercept over here. No problem. Because it's still an x value, yes? But it would be a negative x value, right? Why would it be a negative x value? Because it is directionally on the left of 0.
Then wouldn't your y be negative?
It would be.
Would you draw the negative?
No, you would write it as 0, comma y, because it is still a y value. If you are speaking in general terms. You want to be specific, you could say this was 0, negative y, if you wish. Everybody cool? All right, let's apply this knowledge to our situation here. Notice I have a function, yes? In grade 9, how would we have written that? Y equals 2x plus 3. Since we're graphing, we're going to use that. Everybody cool? Now, I want the x and the y intercepts. Every x-intercept is what? X comma 0. Every y-intercept is what? 0 comma y. Do I know that value? No, it's an x value. Do I know that value? It's 0, and it's a y value, correct? What do I see right there? Y. So what can I write there? 0 equals what? 2x plus 3. Now what do I do? Algebra. So what do I do? Minus 3, minus 3. Negative 3 equals 2x. Now what? Divide by 2. So what does x equal? Negative 3 halves, right? Which is negative 1.5, which is negative 1.5, which is all the things that negative 3 halves is, right? Now, negative 3 halves equals x. What do you see right there? So what can I write right there? Negative 3 halves, comma 0 is a point on our graph. Now what do I do with the other one? Same thing. What value does that 0 represent? What value does that y represent? Y. Y equals 2 times 0 plus 3. What's 2 times 0? 0 plus 3? 3. Y equals 3. What can I write there? 3. 0, 3. Now, do I have a point on the graph and another point on the graph? Once I have 2 points on the graph, and since I'm in the 10th grade, I'm only dealing with straight lines, can I now graph this? Yes. But we are still faced with a problem. What is the problem? 1 second, Preston.
Well, I have a question.
I have an answer.
Okay, I don't get how you got y equals 2 bracket 0 bracket plus 3.
Why? 0 is an x value because it's the first thing. That's an x. So I put 0 for it. Okay. So now we have a fraction, so we're in trouble, aren't we? But we're not in trouble because we're intelligent people. I could say, oh, negative 3/2. That's 1.5, isn't it? Well, there's negative 1, there's negative 2. Where's negative 1.5? Right in the middle. And y is 3. 1, 2, 3. Easy peasy lemon squeezy, right? But allow me to show you this that makes it even easier. I'm going to say that 2 squares equals 1. So what is 1 square? A half. So I need 3 halves, don't I? 1, 2, 3. I can go out to here, and then I don't have to be guessing. It's exact. Does everybody understand what I did there? If that is 1, what is that? So if that is 1/2 positive, what is that? So what is that? Negative 1. So what is that? Negative 1.5. So I could put my dot right there, and then it is exact. I don't need to be worrying about putting it halfway between 2 little squares. Now that causes us a further problem. If the x-axis has been spread to each square being a half, what should I technically do to the y-axis? Do I have to do the same thing? No, of course not. But I can in this case because y is 3. So 1, half 1, half 2, half 3. It fits on my graph so I can keep the same scale. Do you understand? Yeah. If it doesn't fit on the graph, I can't keep the same scale. Okay? So, since it fits, I am going to keep the same scale. How will I show Mr. Myers that I have changed both scales? By writing 1. Because I recognize that that means each square is a half. 1, 2, 3. And then I can draw that line, and it's just bigger and easier to graph. Okay? Yes. You are in charge of the graph. It is not in charge of you. Okay? Excellent.
Excellent.
Just to remind you, because normally I do this lesson the day before I do the functions test, I throw in a domain and range here. What is the domain and range of a straight line? How long will this line go this way? How long will this line go this way? So what is the x values? All real numbers. How long will the y's go? Infinite. X is a set of real numbers. Y is a set of real numbers. Yeah? Now, number 3. Does it look different? Yes, it looks different. Is it different? No, because I want intercepts. What is every single x-intercept? x0. What is every single y-intercept? 0y. Sub into the equation. 0 equals 1/2 x minus 2. How do I solve that? Oh, I should have used blue. Sorry, because I did... Sorry. Plus 2 plus 2. 2 equals 1/2 x. What does x equal? Half of 1 is 2.
Times 2. Half. You multiply.
The screen is blank because it is over my head right now. And all the words that I wish to say would be blanked out.
Yeah, I've been this for a long time.
What is x? 4. Yes, 2 of you did. 28 of you said, I don't know, 1, 0, 7, 29, 312, 8, the cube root of 7, 9, 47. I don't know. And then over here we do the same thing. Y equals 1/2 0 minus 2. Y equals -2. And then I go to my graph. X equals 4. 1, 2, 3, 4. Y equals -2. 1, 2. And then I make my line. And of course, since it is a straight line, the domain is all real numbers, and the range is all real numbers. Yeah? Yeah. Now, next thing. You see a word here that we have used before. The word is slope. When we were talking about slope, slope was a rate of change. Because in all our previous graphs, two things were happening at once. Time was going on, distance was going on. Time was going on, height was going on. It didn't matter. There were two things happening at once, so things were changing. Specific things, IVs and DVs. Well, now we are talking about in general. X's and Y's. And we are going to talk about that as it is discussed in general terms, which is a slope. Now let's take a moment. Let's have a look at this. We all know what Y is. We all know what X is, correct? Yeah. Okay. M equals the slope, which we know to be rate of change. And we know we found that rate of change by finding our change in the dV and dividing it by our change in the IV, right? But we no longer have dVs and IVs, do we? Because we are not talking about a specific case. We are talking about all the time. So the dV and IV becomes the change in Y divided by the change in X. Everybody cool? All right, so that covers slope. That's one of the new things that we have in this new form that we are talking about. So we now know we already knew what X's and Y's were because we've been through grade 7, 8, and 9 math, and we've all played Battleship. We now know what M is because we knew what rate of change was from the last unit. So all that's left here is the B, right? Okay. I want you to look at something. Does this look like Y equals MX plus B? Why? M is a coefficient with x, and B was a number all by itself, a constant. Everyone agree? Okay. Does this look like y equals mx plus b? Excellent. Now, what did you notice about that number in both cases when I went over to my graph? -2, -2. Yes, I know that's what you said. +3, +3. This number is the y-intercept automatically. And of course, it's easy to see why it is the y-intercept, isn't it? Because the y-intercept is 0, y. And that 0 would go in for that, which would eliminate the whole term, leaving you with just that number. Is everybody cool? Okay. So let us apply this to knowledge. Here I have a line, correct? That line is not on a graph right now, is it? It's just a line on the piece of paper, right? Everybody make it so it's on a graph. Everybody cool? Here is the first point on the graph. That is point A. Here is point B. I want to know the slope of this, which means I have to check the change in y divided by the change in x. Everyone agree? How do I measure y's on a graph? Up and down or horizontal? Up and down. So I need to get from A up to B. So I go up there, correct? Since I went up, is it positive or negative? It is positive. Then, to get to B, I must go this way, which is right. That is also positive. So my change in y was a positive number. My change in x was a positive number. So I had positive divided by positive. When they're the same sign, what do I get? A positive slope. This is what we call a positive slope. Now, some of you will say, yeah, what if we went the other way? Cool. Let's go the other way, from B to A. What is that? Negative. What is that? Negative. Negative divided by a negative is what? Also positive. So that is why this is a positive slope. Okay? Now let's... What? No, it's an arm with a hand waving at you, Ganika.
Why is that window so humongous? Do you have a problem with that?
Once again, you can mock my drawing all you want.
No, I'm just asking the question.
Okay, it is a big window. He's very rich. The whole wall is windows.
Good for him.
All right. This one, there's A, there's B. What's the slope? Remember, I do change in y first. How do I get from A to B? Negative. And then over this way, two different signs. So what's this? A negative slope. Everyone understand?
Do we ever have to have a number for the slope?
You will. We'll get to that. This is the concept behind it.
It's kind of like trigonometry.
Now, what about this guy? A, B. What's the change in y? Positive. What's the change in x? Nothing. So it will be positive divided by 0. Can I divide by 0? No. This is an undefined slope because it is technically infinite, isn't it? I like to remember this like this. If we all went out and decided to go sledding, there's our sled. There we are sitting on the sled. Yay! We would slide down, right? And then, of course, being kids, you would get off your sled and walk right back up the slope where everybody is trying to sled down. You would all get run over. You are all laughing because you all indeed do that. Even though your parents, when you were little, took you sledding and say, walk around. And then, no, you walked right up the middle. And then your parents said, don't walk up the middle. And you got hit and plowed by some kid on a sled. And no, I lie. I've skipped a step. You said to your parents, I won't get run over. And then 2 seconds later, you got run over. Because, of course, you plan for accidents to happen, right? That's why they're called accidents. Never mind. If I go to this one and try to sled, what happens? I do not slide down, I fall. You cannot sled down an infinite slope.
You can sled down, you just fall down.
Because it is not, this is not sledding, this is falling. Okay? Now, what about this one?
It's not sledding because it doesn't have sled.
A to B. What's the up and down? There is none. Divided by a positive. I have no pizza. Let's split it up. How much pizza do you get? None. So this is a zero slope because it wouldn't be very fun to try to sled on it. Unless, of course, you have your dog on a leash pulling you along, which is what I do every time it snows. I make Cooper pull me to the sled. We pretend he's a sled dog. And I go, mush! And he goes, moo. But he's a lazy sack of crap, so he only pulls me about half a block, and then he's just like, you're an idiot. I'm like, good, it took you half a block to figure that out. If you, of course, hook up a cat to a harness, the cat will claw your eyes out, because the cat knows that you can walk there by yourself. Okay? Okay. Slope equals M equals. And then I have a big set of blanks because slope is a whole bunch of stuff. What do we already know it is? Rate of change. Change in dV over change in IV. Now we also know it is what? Change in Y over change in X. And it is also what we call the rise, up and down, divided by the run, side to side. Okay? And actually, that's where we're going to leave that. Is everybody cool? Delta, it's a triangle. I used it in the last unit as well. In physics, the triangle means change in. Okay? Okay. Turn the page over. So now you know what slope-intercept form is. It is y equals mx plus b. What do you know about b? That is the y-intercept. What do you know about m? That is the rise over the run, right? So let's start, and I'm going to use purple to do this A. Where should I start my line? Which of those two values is a point on the graph? The negative 4. Where is negative 4 on the y-axis? Down 1, 2, 3, 4. Now, can I draw a line right now? I can. I can draw an infinite number of lines. Can I draw the right line? Yes, but it's going to be very specific. It has to be a line with a slope of 2. How should 2 really be written? 2 over 1. Hey, that's a fraction. On the numerator is the rise. The denominator is the run. So if I rise 2, where should I go? Up 1, 2. If I run positive 1, where should I go? To the right 1. Now, just to remind you that this goes on for infinity, I could also go down 2 and left 1. And that gives me the line. Does everyone understand? Do what third one? I don't care. You should, to make sure you have done it right. Because if you do it poorly, your third dot will be over here. And that's not a line. Because just like I drew up here, Preston, negative negative is still a positive slope. Brendan. Because every single number in the universe is always the fraction, that number over 1. That's what a rational number is. Now, you guys now try to do B. Choose a starting point and figure it out. Talk to your neighbor if you need to. I'm going to wait a second for you all to draw it, then I'm going to draw it. Now, who is willing to tell me where I should start this function? On what axis? The y-axis, right there. Can I draw a line yet? No, I have to have at least 2 points, preferably 3 points. So, what is my slope? Not 0. Negative 1. This slope is negative 1 over 1. So, how do I rise negatively? Go down 1. How do I run positively? To the right 1. Or, can I rise 1 and run negatively? Yes. And there is my slope. Could I have gone down 22 and right 22? Yes. Could I have gone down 938 and right 938? Yes. Could I have gone down the square root of 7 and right the square root of 7? Yes. Preston. As long as one of your directions is negative, you will get the slope correct. Everybody try to do C. You know how to do it. It looks different, but you're going to apply your knowledge and you're going to figure it out because you're intelligent young people. I will wait a moment for you all to decide where to start and then decide how to address the other part of slope-intercept form. Where shall you start? 5. Now you need a slope of negative 1/3. Which of the lines that I have already drawn is negative? The purple one or the green one? The green one. Now I have a fraction of 1 over 3 and I have to make sure I am leaning this way. So I will drop 1 and then what? Go to the right 3, or I will go up 1 and left 3. There is my negative run. There is my negative rise. Both of them will work, creating this line. Now, what do you notice about the lines? This guy had a slope of 1. This guy had a slope of 2. This guy had a slope of 1/3. As the numbers get bigger, what is happening to the slope? It is getting steeper. 2, 1, 1/3. And that makes sense because straight up and down is infinity and flat is 0. McKenna.
How do you know that when you're go up and then to the side, how do you know which side you're going to
One of them has to be negative if it's a negative slope. If it's a positive slope, they both have to be the same. So from any point, if I go up 1, that's positive. So to get this negative value, I would have to go negative. If I went down, that's negative. So to get the negative value, I would have to go positive that way. Okay? Excellent. And lastly, D looks weird, but again, intelligent young people, you can do it. What is the y-intercept? 0. What is the slope? Positive 1. So if I went up 4, how far to the right would I need to go? 4. If I went down 6, where would I need to go? No, I've already done the down 6. If I went down 6, where would I need to go? Left 6. Yay! Now, down 1, 2, 3, 1, 2, 3. There's our line. Now, as previously promised, I said to you, you guys, the first couple of lessons of this unit are very helpful to the unit we just did. And here, indeed, is some of that help. F of 2. What color line is the F line? Purple, indeed. Is that an X value I am seeking or a Y value I am seeking? That is an X value. That X value is what? 2, which is right there, correct? What is the Y value associated with that point? 0. Excellent. What color is the H function? The light green one. Is that an X or a Y value? X value. 1, 2, 3. There is 3. I need the Y value that corresponds with that. What is it? 4. Lovely. What is the G function? Which is G? Dark green. What am I looking for? I need an X value. I have a Y value, which is what? 4. So I go up to 1, 2, 3, 4. Here is the level I have to be at. Right now, my line doesn't make it there, does it? But can I continue that line? Of course I can. There, there.
Isn't that 5? Is that...
1, 2, 3, 4. Oh, it is. Thank you.
That's what I was...
Thank you, thank you, thank you. 4 is right there. So that's where I need to be. And what is that X value? What kind of 3? Negative 3. And lastly, back to the purple one. What is the value of X when I am at negative 1 on the Y values? Negative 1, X. Oh, it's right in the middle. Can you tell me exactly from the graph? No, you can give me an estimate. Can you tell me exactly if we use algebra? Yes. Everybody cool? All right. What? Okay.
What do you write for D?
Well, you could just give me an estimate, because it looks like it's right between them, right? Well, it is right between them. Or you could use algebra. Since we have the graph we're going to estimate, it is between 1 and 2. It looks like it's about halfway between, so what would a good estimate be? 1.5. Now, if we wanted to be exact, it was 2 f of x equal 2x minus 4, correct? F of x is negative 1, so negative 1 equal 2x minus 4. Add 4 to both sides. 3 equal 2x, x equaled 3 halves. Hey! We're brilliant. Gouda? Great. Now, Now, you are going to skip over this work because you're going to do a bit of it on your own, and you're going to go straight to 6.2.
This is going to be on the test.
No, this is on chapter 6's test. Now, normally I stop right there and I let you practice it, but over the past couple of years, I have noticed that from the day we do the first lesson that we just finished, and then you practice it, and then I go on to Understanding Slope, everyone forgets it, and I have to go back and teach the whole first lesson again anyway. So that is why I'm crunching it together for all of you, because I'm tired of having to teach the same lesson twice when they're only 24 hours apart. So we are going to do this here now. Slope means a bunch of things. We are going to be graphing a line. So what definition of slope do we want to use here? We want to use rise over run, don't we? Now, everybody listen to me because I want you to do this properly. In this quadrant, I want you to do E. In this quadrant, I want you to do F. In this quadrant, I want you to do G. And in this quadrant, I want you to do H. Now, everybody randomly put a dot somewhere, anywhere in this quadrant. Everybody put a dot randomly. I'm going to put mine there. Everybody cool? Now, is a dot something with a slope? No, what has a slope? A line. So I need a line, don't I? That line is to have a slope of 2/5. How do I make that from my random dot? I would rise to. How would I rise to, Suhani? I would go up 1, 2. Then what? Right. 1, 2, 3, 4, 5. And there is my line segment with my slope. Everybody got it? Now you guys do the next ones. Start with the random dot. I want everybody to have a different dot so you can see that whatever your x and y values are, it doesn't matter. Slope has nothing to do with x and y. It's the rise and run of the line. Now, please notice that in my drawing, I have done 3 of them, haven't I? All starting at different points, right? But notice that all 3 of them create exactly the same line because it doesn't matter where you start. Slope is directions from a point. It has nothing to do with the specific x and y that you are dealing with. Everybody cool? G, slope of 0, that's an easy one. What's that one look like? Flat line. Because you're not going to be able to sled on that very well. And H, is H going to be steep or shallow? How do you know it is going to be steep? Because it's a bigger number. H is the black diamond run. Everybody good? Yeah? Everybody can draw a line. Everybody can draw a slope. Yes? Good. Now, look at 2. Do I still have a graph? Do I still have a graph? Excellent. Can I put this point on these 2 points on this graph? Excellent. Let's do so. Where would negative 5, negative 3 be? While you're doing that, I'm going to be zooming in. Because for this, it's nice to have this very large. Where would negative 5, negative 3 be? Everyone agree that that's negative 5, negative 3? Yeah. And where would 2, 1 be? 2 to the right and 1 up. There's my line. Now, since I am on a graph, can I count? Yeah. It's so easy, isn't it? How do I get that slope? I count the rise and the run. From which point, Sean? Does it matter? If I go from here, what's the rise? 1, 2, 3, 4. Positive 4. And if I go then run, 1, 2, 3, 4, 5, 6, 7. Positive 7. So what's the slope? 4/7. What if I go the other way? What if I start here? 1, 2, 3, 4. Negative 4. And then I go this way. Negative 7. Negative 4 divided by negative 7 is the same as 4/7, isn't it? Everybody cool? Ease bees lemon squeezy, right? Okay. What about the other one? 0, 4 and 0, 0, negative 4 and 0, 3. Well, that's even easier, isn't it? 0, negative 4 and 0, 3. Hey, what kind of slope is that? Undefined, because it's straight up and down. Can everybody find a slope on a graph? Yep. Put a dot, count. Can everybody get the slope from a graph? That's this. Go to the line, go to 1 point, count. Everybody good? Turn the page over. What's happening at the next question? Do I have the graph anymore? No, I do not. But since I don't have the graph anymore, is rise over run going to be helpful to me?
Yeah. I mean, yeah, but you need to draw it.
But I would need to draw it, right? Okay. What are some other definitions of slope? Change in y over change in x, right? Okay. I'm going to highlight 2 things. Tell me what they are. Those are y values, aren't they? How do you tell me the change in y? What math tells me the difference between things? Subtraction. So, if I do 7 minus 1, will that tell me the difference in the y's? Okay. Then, what would I need to do with 2 and negative 6? The same thing. 2 minus 6. Which is, thank you, you just gave away my next one, 2 plus 6. What is 7 minus 1? What is 2 plus 6? 6 over 8, which is 3/4. Now, do I have a rise and a run in the slope? Yes. So, what did I do here? I did y minus y over x minus x. Except I can't write it that way, can I? Because what is y minus y? 0. What is x minus x? 0. I put not above, because then everyone goes, oh, it's squared. We put them down here. 2 and 1, 2 and 1. Because I have 2 y values, that's supposed to be a y, it's just hard to read. X. Now, who decides which is y2 and which is y1? You do. In my version, the way we just did that, where is y2? It's the 7, y2. If that's y2, what does that make this guy? x2. And that makes this guy what? y1. And this guy what? x1. Everybody good? So, knowing what you know, tell me the slope of these two. 4 minus 15 over what, Sean? Negative 1 minus 5, which is 4 minus 15 over negative 1 plus 5, which is 4 minus 15 over, 4 minus 15. Negative 11 over 4. Done. Is everybody good? So now you can find the slope from any random point by counting. If you actually have the graph, you can find the slope by counting. If you don't have the graph, you can find the slope by addition. How are we going to find these four slopes? Are they on a graph? Yeah. Say it. Keep going. One point to another. Which point should I use? Well, it does matter. Can I use that one?
Yeah, that's what I meant.
Yeah, but can I use that point and that point?
Yeah.
Why not? They're random. You don't know exactly where they are. So, tell me as I slide my pink circle here down the line, where can I stop, which would be a spot I could use? There? And where's the next one? There? There? There. Now, do I have 2 points that are nice and exact? Because this slope is going to be the same for the entire line, isn't it? What is that slope? No. Pardon me? 7 over negative 2. Negative 7 halves. Okay, let's do B. Can I use this point? Tell me when I can stop.
Use that one. Yeah,
Tell me the next time I can stop. Nobody said stop. It's not a complicated game. All you have to do is say stop. Okay, I'll go back to here. That one? That one?
It's the second one.
Yeah, you can do it.
That's correct.
What about that one? What about that one? What about that one? Are they pretty darn close? Would I be happy if you said this slope is what? 1 over. Would I be happy with that? Does that show me you understand the concept of rise over run? Does that show me you know that you should get as close to the possible points as you can? Does that make me happy? Yes. Damn it. Tonight, have a look at that work I didn't get you to do now, whatever page it was, 226 or 7 or whatever.